take skew. Similar, exactly similar example. Instead of latency, it will be skew. Two flops are there, right? I need a skew of 80 ps or 90 ps or 100 ps, which means my skew constraint is less. I'm not too much worried about the skew. Then what the tool will do is it will add one buffer here, two buffers here, let us say, right? So the latency for this will be some 290, and the latency for this will be 200. Sorry, let us reverse this. This will be 290 and this will be 200, and therefore the skew is 90 ps. Now if I want stringent skew 50 ps, what does the tool do? What does the tool do? It will try to push this, right? This 200, it will try to make it 240. Now this 290 minus 240 will be 50 ps. In order to balance the skew and make it 50, it has added two more extra buffers, right? So therefore my skew value has affected the number of cells getting added to my design. Let us take the third thing, my metal layers, metal 2, metal 6. Which of these will have higher resistance or which of these will have lower resistance? Either way,
Metal 6 will have low resistance.
low resistance,
Metal 2 will have high resistance.
high resistance. If a metal 2 has high resistance, which metal is possibly occurring more delay?
Metal 2, sir.
Metal 2.
Right? So definitely if I use metal 6 for my clock routing, I can drive longer. And hence I will add less buffers to my design. Right? If I'm using metal 6, my drivability of the net will be longer and I will add less buffers. Metal 2, it will be thin, so I have to add more buffers for the same distance. Resistance is high, delay is high, more buffers needed. Right? And buffers we already discussed, right? 2x and 6x. If I use 2x, I need to add more buffers since it is a smaller cell. 6x, it is larger, I need to add less buffers. Again, if the size of 2x is 1/3 of 6x, or if 3 into my 2x cells area is equals to 1 into my 6x cell area, what is happening in this case? My utilization, will it increase or decrease?
Remain same, sir.
Remain same.
Absolutely correct, right? So this is what will happen. If this is not the case, these are not equal. If this is higher, then utilization will be higher in 6x. If this is higher, utilization will be higher in 3x. So now we were talking about sudden utilization jump between place opt and CTS. So while doing clock tree synthesis, all these factors mentioned here will affect how many buffers I will add or how much area, gate area I will add to my design, right? So these should be carefully chosen. These values, either the skew, latency, or the metal layers that we are using for CTS, or the buffer drive strength that we are choosing, these should be very carefully chosen to reduce the amount of area we are adding to the design. Since sometimes our primary target will be skew, our primary target will be skew and latency, because that will directly affect the timing. Sometimes we tend to use more area to balance the skew and all. If skew is not that of a problem, we should look at reducing our buffer count being added in the CTS, right? So this abnormal jump is due to improper values that we have given to build the CTS, and that is why the tool has added unwanted number of buffers in the design. Got it? Apart from these, we will also give a clock transition value. So max transition is not only for the signals, max transition will be there for clock also. If I set the transition limit as too stringent, let us say 50 PS of transition is the max limit, the tool will definitely try to meet that and add more buffers unnecessarily, right? So we have to set proper transition limits also. Due to all these factors will affect my utilization. If there is an abnormal jump, like Lokesh was mentioning, it will be due to improper values or targets that we have set to build the CTS. Understood, or any doubts?
Yes, sir.
Yes, sir.
Understood.
Understood, right? Now, will utilization always increase from place to post route? Will utilization always increase? Place to post route. The answer is no, right? Usually we see utilization increase. In the interview, you can say I started with 65, then 68 at place opt, CTS 71, 73, 75, right? And the interviewer will be happy. You might sometimes see the utilization also dropping. Let us say place or floor plan, I will mention here. Floor plan utilization is 65, place opt utilization is 63. Can this be the case? Yes, it can be the case. Why? Because in place opt, I will get buffers getting added for high fan out net synthesis and transition fixes and all. But also sometimes what happens is the tool will remove unwanted cells. Tool will remove unwanted cells. For example, let us say there is a flop which is not connected at input or output. Floating gates, right? Floating inputs is fine, or floating outputs. I mean, one connection at least on the input side or the output side is fine. But if both are not connected, this cell itself is not used in the design. So the tool will just remove this cell or delete the cell from your netlist. If you have a lot of these kind of cells, the tool will remove these cells and reduce the instance count in your design, thereby reducing the utilization. Thereby reducing the utilization. Got it? Now, you must have also heard about cell padding and module padding. What is cell padding? Anyone? Or sorry, I think or cutoff, guys, it is keep out margin, right? Keep out margins.
We will call Halo also, sir.
Halo also, fine. Whatever name you call it. What is the meaning of halo, cell padding, keep out margins? Why do
We
we
will
use
define some boundary to the standard cells or macros, sir.
we will define some boundary. So boundary will already exist, I guess, for standard cells and macros.
When there are high pin density cells, we use keep out margin around a cell.
For
When there are high pin density cells,
correct. For what reason?
to
For any
overcome that congestion problem.
to overcome congestion. Sometimes I will put keep out margin, which means my width is 5 microns or 10 microns, height is 4 microns. I will just bluff my tool saying that if I say cell padding 1.5 times, right? Cell padding of 1.5 means this 10 microns will get multiplied by 1.5. What does it give me? 15 microns. So we will tell the tool, since there are high number of pins for this cell, I want some space for the routing. So if I define a cell padding of 1.5 times, I am bluffing the tool saying that the size of my cell is not 10 by 4, it is actually 15 by 4. How will this help me is, no standard cell will get placed in this region. Here another standard cell can get placed. Again there will be pins for that standard cell. Here again there will be pins, right? To avoid that, I am giving a padding wherein I will have ample amount of empty space around that standard cell. So now once placement is done and all, once placement and routing everything is done, this empty space, whatever we did not use for standard cells, is left out, right? So this is unutilized space, and my utilization, if I remove the cell padding and all, it will reduce, right? My utilization, since the space is not utilized, it will reduce. I am bluffing the tool just for congestion's sake that it is bigger than usual. But in reality, once everything is done, once routing and everything is done, this space is not actually used. It is empty, right? So this is cell padding, and this is these are floating gates and unconnected logic, basically unconnected logic or floating gates. So many flops will be removed. If you look at your log file, place of log file and all, it will show you deleted these many flops. So deleted 100 flops because they are not connected. Deleted 30 flops because they are not connected. So this deletion of logic will cause your utilization to drop down. But you should never mention this drop. Even in your designs, if the utilization has dropped from 65 to 63, it is always good not to mention this in the interviews. Never mention utilization drop. Right? Nobody is going to come to your VNC design and check whether your utilization has actually dropped or increased. You will have hundreds of questions if you say this. So always avoid saying utilization drop. Even if in your design it has actually dropped from 65 to 63, just say it has increased 65 to 67. Put some approximate number and say that it has increased. It is always good in interviews if you can avoid cross questioning, right? There will be many corner cases in the design. So these cases will actually help you. This can be used to your advantage if you are very thorough with the knowledge behind why the utilization has dropped. You have actually checked the log files, you have actually studied your design, and you're very thorough, okay, about what has happened in your design. Then the interviewer will get impressed, right? So this guy is actually looking into each and every aspect of the design, and he clearly knows why the utilization dropped. But if you think you only know partly or you don't have the complete knowledge of it, better not to tell these kind of things. Okay, just say that my utilization has gone up from 65 to 67. So these are some of the important things in your. Why I asked you to come up with this sheet is, why I asked you to come up with this sheet is, just by looking at this sheet I can tell whether you have worked on a design or you just put some numbers, right? So nobody will tell it to you on the face. They will just keep asking questions and all, and they will just tell your HR team or your leads so and so person is not selected. They will not even mention the reason why they are not selecting you, right? So looking at these values itself, an interviewer can come to know whether you have worked or not, right? So that is why these values are very important. Like for example, the utilization drop. This can happen, but better not to put it in your design or design stats. Understood? So